everyone. How you holding up? It's been a long day. Doing okay? Still awake? Good deal. So, yeah, I'm got good news and bad news, and they're the same news. I'm not an educator, so I'm not going to speak your language, but I will show you what some of your folks that you send to us as engineers or other folks will do in the real world. I came last October, I think, over to the Watts Center at Clemson, and I talked to the virtual reality club there. Great group of kids. It's a really beautiful facility, and they've got a lot of nice equipment, and that's how I got invited back to this. So Jacobs, Engineering News Record, which is a kind of an industry Bible, it's construction industry. It rated last year the top engineering firms in the world were AECOM, Jacobs, and CH2M in that order. And you see on some of my stuff it says CH2M, and the things we were giving away said CH2M. So Jacobs bought CH2M late last year, and Jacobs was 2 and CH2M was 3 in terms of the ranking. So I think probably that puts Jacobs as the #1 engineering firm in the world now. There's about 75,000 engineers that work for Jacobs. Scott and I, Scott Yankee over there, who's our VR lead developer, we're out of Cincinnati. There is a big Jacobs office here in Greenville, but we're in Cincinnati, and there have been several different blooms of VR development in CH2M and in Jacobs around the world. So it's us in Cincinnati. There's a group out of Glasgow in Scotland. There's a group out of Bellevue in Washington. There's a group out of Atlanta for Jacobs. And we've done a little bit of work with Jacobs, but mostly it's been our work with CH2M that's gotten us to this point. And it's been really cool because I'll give you a little history of how we got here. This is not really our job. I lead a group of packaging and machine designers. Scott is a senior piping designer, so that's what we do in our real job. But we've kind of taken this VR thing as under our wing as a hobby, and we've turned it from a hobby into a commercially viable thing that clients are clamoring for. So good for us, I guess. So really, I'm starting with a Star Wars thing, not a Star Trek thing. We did not collaborate, me and Sean. But if you remember when The Force Awakens came out back in 2015, it was the first foray into Star Wars for Disney, and they were really marketing the heck out of the movie. And one of the things that they sent out were these little cardboards, and they were themed to the characters, and I chose the Kylo Ren, not even knowing who he was, because I didn't know that much about the movie. But they sent out these free cardboards, and I got one, and I did the standard things, and I loaded the app on it, and I looked at Paris, and I went to the Great Wall, and it's like, yeah, that's cool, but I'm not a gamer. I haven't been a gamer for a long time. I used to play Adventure, and I talked to Eliza and that sort of stuff. I've been in engineering for 30 years, but I saw this, and I thought, man, if we could get our models into 3D VR, wouldn't that be nice? And so I took it in the office the next day, and I started going from desk to desk, talking to people who I thought it might resonate with. So I took it to my boss and showed it to him, and he's kind of an old-fashioned guy, and he remembers when they used to use drafting boards, and he looked at it and he's like, yeah, that's kind of cool. So what? And I took it to a few of the project managers, and I showed it to them, and a few of them were like, yeah, that's kind of cool, and I took it to Scott. He's like, yeah, this is really cool. We could do something with this. So we started trying to figure out how to do it, and no one told us how it was done. So it's, Scott figured out how to use Unity and how to make the conversions from the engineering software. We do almost everything in 3D now. There's no reason not to design in 3D. So a lot of this stuff was there for us to be able to make the conversion. And so this was fall of 2015, before any of the big VR hardware came out. So the development kit for the Oculus Rift was in some people's hands. The commercial kit was not out. It went on pre-order in January, and we ordered one immediately, but it took 6 months to get. So we started running with these cardboards. So, we had the Kylo Ren first, and then we found a place in England that would make these things for us, customized, and so we started putting our artwork onto them, and this is like the generations that we went through from purple to cyan to orange, and those were just official CH2M colors and CH2M artwork, and we gave away hundreds of these things to clients and students and job fairs and just kind of, getting the interest up. About $8 when you buy them in hundreds. And it's kind of cool because there's a place over there that they send you the templates in Adobe Illustrator, and you have one of your arty people do it for you. You email them the artwork back, and in about 2 weeks, a box of these things shows up from China. And they're nice. They're really good cardboards. Oddly enough, the best cardboard we found was that little thing in the back. It's made by Mattel. A lot of the younger folks will not remember, but the Instamatics from back in the day where you click the little wheels, that's what that's made to look like, and they included a little wheel that you would stick in there that would take you to various virtual reality places, but that's a great cardboard. The only problem is you can't strap it to your head, you just gotta hold it up there, so you can't use any controls. So, getting down to the nitty-gritty of why we wanted to do what we're doing. There's a lot of problems when it comes to design review with engineering. The first and biggest is a lot of people who need to be able to understand what's going on with what we've designed for them don't read prints. 2D, hardly at all. 3D, maybe a little bit. And even if you take them through a 3D simulation, like Navisworks, they'll look at it and think they understand, but when you build it for them, they go, oh, that's not right. That's not right. I should have seen that earlier, but I didn't. So we would like to get much earlier engagement with the design team. So you got, your corporate stakeholders are the guys who have the money. They're the guys who are, funding the millions and millions of dollars to build the project. You've got the folks who are going to operate it on a day-to-day basis, who are going to whine the most when it isn't like they want it. You got the maintenance folks who are going to try to keep it running. The construction folks who are going to put it in. And then you got all the trades, all the vendors, and then the safety folks. And they all need to see it as early as they can and understand it. We find that too many times they don't. They say they understand. They sit in design reviews, but they look at their laptops, or they look at their phones, or they take a call, and they don't pay attention. And so that's a problem, and it's an expensive problem, because if we can find things that need to be changed early in the design phase, when you're just moving around bits and bytes and changes cost hundreds of dollars an hour, because that's what they pay us, versus when it gets in the field and you have to change steel and concrete and it costs tens of thousands or hundreds of thousands of dollars an hour to change something, big deal. Another thing we found out was a lot of the traditional 3D review tools have a high learning curve. So you could learn to use, say, Navisworks, but you have to understand all the different mouse clicks and the key combinations and the modes. And if you don't use it enough, the next time you get in there to use it and someone says, hey, I've got a design for you to look at, please check it out. They pull up Navisworks and they go, I don't remember how to use this, so I'm not gonna look at it. I'll wait, I'll put it off. And so they don't make the input they need to make when they need to make it to save cost. So another thing we found is that a lot of the people that need to see this are far-flung. There's a lot of manufacturing that's done overseas. One of our main clients tends to pick places to put plants that are way out in the middle of nowhere in the boondocks, so it's hard to get to. So trying to get everyone in to see these things and to collaborate on a WebEx, it just doesn't work too well. And I mentioned the difficulty in keeping the audience focused and participating, but our main client has this level of spend on a project that if you go above that level of spend, you have to bring in everyone into what they call their Envision Center. And they got 6 of them around the world. They're networked, they talk to one another, but they're kind of a pain to use because you gotta get them the files a couple of weeks ahead of time. They have to prepare the files. There's a full-time operator that sits there with the system. And you may have seen it before. I think it's called the K4 system. What's the company that makes it? But what it is you go to this special room, it's maybe half the size of this room, and it's got this big black projection area where they project the model in. You have to wear 3D glasses. And there's a sweet spot. If you stand right here, it looks like it's supposed to look. If you stand over here off axis, it's not quite right. And so you got 15 or 20 people kind of clambering around the sweet spot, trying to see what they're trying to see. And it works, but it could be better. So what we did is we made it better by taking our models and converting them to VR and allow them to see them much more quickly. We can make changes in a few hours versus a few days or weeks. And this is kind of the way we've come. We started on the cardboard, and we started running into some limitations with navigation because it's only a push button and turn your head. And then we went to the Gear VR. So we had Bluetooth controllers, Samsung S6 phones is what we were using at the time. And these worked really good. In fact, the clients still like them to the point that they ask for them, even though we would rather not use them because we run up against the limitations of the phone's processors. But what we were doing is we would take these things and we'd put them in hard cases. We'd put like 3 sets, so 3 phones, 3 controllers, 3 Gear VRs, and we would send them off, and we would have them loaded with the model, and they would have a box account and an email account. We could update the models remotely. And then it's nice with the Gear VR because those simulations only work with those phones. So it's very secure. You can't just hand that simulation off to someone else and no one knows about it because it won't work on anyone else's phone. So that worked great, and probably, I don't know, a couple dozen of those kits or a couple dozen of those systems were sent out. And it really got us to the point where when the Rift finally came to us the middle of that next year in 2016, and we started developing for the Rift, we started seeing that that's the way we need to go because we're not limited now by the number of polygons usually. I mean, there's still things that we gotta simplify, but the Rift is really where we are now. Now, this is what we're doing in our offices. These are some of our clients, and they were looking at their design on a couple of screens. They'd never used VR equipment before, either one of them. The guy, I think he was a gamer, he'd done a few things, but he'd never had a VR headset on. The girl wasn't even a gamer, but they were in there being effective in making comments and changes to their design within 30 seconds. It's that easy to use. There's no learning curve. You just put it on and you're moving through the model. So we now have larger screens for both systems. She's on a laptop, but we got a couple of big screens now. And we tried going to laptops, but they don't work as well for us as desktops do for some reason. I guess maybe it's just data throughput. The laptops aren't as good yet. But what we found with doing this is one of the most important things is a sense of scale with people and their designs, because when you're actually standing there and you can make good comments as to how well this is going to work in the real world, and will my guy be able to get in there and work on this, and is this safe, and can this fit, it's invaluable. We find a lot of operational inefficiencies really early. We find safety things that you would never see if you were just looking at a model from afar or looking at a 2D print. And then the biggest thing for us and for our clients and why this has become viable is the cost savings. We don't really do anything unless it saves money. We don't do it because it's nice to do. And they've bought into it to the point that it's a requested feature now with our projects. And we try to offer it to them without charging a whole lot of extra money, because when we do the models, we kind of know how that they should be prepared so that they can be converted to VR quickly, and it's not that big of a deal for us to do. Scott spent a lot of time creating the models, so the conversion process, not to get too deep in the weeds, but we start out with our design software. We've got some formats that we prefer to work with, and then It comes into Unity, and he's got templates that he's spent hundreds of hours preparing, that he's got, his motion control, his networking, his avataring, all of his movement mapping, everything gets applied, and then the VR is built, and we can turn these things out for, we've done them for iOS. It's kind of a pain in the butt on iOS because of all the certificates you have to apply. We've done it for Android, PC. We tried one for Mac, and then we do it for Oculus Rift and then HTC Vive. It's still a work in progress because, like I said, this is really not our full-time job, and we don't have a lot of support and a lot of money to develop. But we know what we want. We'd like to have better multi-user support. We'd like to be able to point with a laser pointer or something within the VR, because you can talk. You're on the phone, you're talking to one another when you're in there together, but it's difficult to stand in a big room like this and go, I want to change that right over there. Well, what are you pointing at? I can't see, I'm off axis. I have no idea what you're talking about. But if we have a laser pointer, we can point to it. How you move through the model is another deal. We have Superman mode where we can fly around and teleport in and drop into things. And we have gravity mode where you have to walk up steps. You have to walk through doors. You can't walk through walls. You can't walk through machines. So it's just how you want to interact with the model. We've had some requests for better material realism. We're kind of iffy on that because the more realistic you get, the more it drags down the model. So if you got a lot of nice shiny surfaces and materials are correct and shadows and all that, looks great, but it doesn't really work that good if you're just trying to get in there and do your job. So if we could get more support from our management and get more money to develop this, which is like one of the things I talked to Clemson about when I was there last fall, is maybe get a CI going, a creative inquiry, to figure out how to get a workflow to build this wish list of things for our VR. That's what I've got. Any questions? We can be. Scott can also take and he can create the VR for PC. So if we've only got 2 or 3 headsets, but we've got 40 people in the design review, we can actually project the VR onto a flat screen. So it's not going to be immersive, but you'll actually be able to see where the people are walking within the VR, and you can see what they're looking at, and you can see what they're talking about. And we've got it down to where that we just have some, floating heads to represent the folks who are in the actual immersive reality environment. But it works well enough when we're got a bunch of people in the room that we know kind of what they're talking about, and we can interact pretty well. Yeah, we've been asked to do that, and we do that. But a lot of times we like to, if the project's big enough, we would like for them to buy seats for the project so that there's not any question about who gets to use it and is it available. We usually tell them it's about $2,400 per seat per Rift system. That includes the computer, the Rift, the hand controllers, and if it's a laptop system, the carrying case. He got a hold of a leap early on, and we were looking at ways that we could like turn valves and open panels and interact with things like that. And it worked okay, but once the hand controllers came out, we just really ignored it. I think it's probably still something that would be good to have, especially for training scenarios, because we've been asked by clients, can we use this for training? And yes, you can, but we're just not there yet. We just haven't had enough time to put into it. But I think it's going to be really good. Even probably augmented reality is better for training than virtual reality, just because you can see things in real life.